today's class is going to be on indices. Alright? Indices, first and foremost, I actually will lay foundation before we start solving questions. Alright? So what is indices? Indices is the plural of the word index. Indices is plural, index is what? Singular. Index numbers, okay, indices is the aspect of mathematics where what now? You express numbers with their powers, right? You write numbers with their powers. So an index number is any number that you write with a power. For example, if I have 5 raised to the power of 3, this means what now? 5 times 5 times 5. I can call this 5 raised to the power of 3, or I can say 5 to the third power, or 5 with an exponent of what now? Of 3. If I have something like 7 to the second power becomes 7 times what? Times 7. I have 7 2 times. This is 5 to the power of 3 and that. This is just basically what I'm talking about. These numbers are what now? Are index numbers. So both of them now will be what now? Indices. Now let me push a little further. Okay. If I have this, for example, where A now is representing any number and M is representing any number, right? A here now is an index number. A raised to the power of M is an index number with A being the base. A is called the base, and then M is called what now? The exponent or the power. The exponent or the power. Alright? So very quickly, I'm going to talk about the laws of indices as fast as possible. Alright? Let me just show you what they are. These are the laws of indices. This is 1, this is 2, 3, 4, 5, 6, 7. These are the most fundamental laws of what now? Of indices. Anything you want to do further will be an extension from this. So let me try and explain them one after the other. Okay. I'm doing this quickly so I can push this. Alright. Let's get back. The first law says that if I have the same base, anytime I have the same base, multiplying index numbers with the same base, multiplying each other, I will just simply add the powers. Simple. For example, if I have 4 to the third power times 4 to the second power, this is going to be 4 raised to the power of 3 plus 2 to give me 4 to the what now? To the fifth power. And in order to make you understand this better, let me try and go by the regular way and then see how this will play out. Alright. So I have what now? 4 to the third power. What does that mean? I have 4 times 4 times 4. I have 4 to the second power. That's 4 times 4. So if I multiply this by this, 4 to the third power times 4 to the second power, I'll have 4 times 4 times 4 for the first one. Then for the other one, I'll have 4 times 4. Altogether, how many 4s do I have now? 1, 2, 3, 4, 5. It's going to be equal to what now? 4 to the what? To the fifth power. And that was what now? We got earlier on. So that's for the first law. Let's run through the second law very quickly. Very quickly. Okay? This is the first law. Sorry about that. First law. Let's keep this somewhere. Keep it. Alright? Let's go to the second law. The second law says that if I have the same base, but this time around they are dividing, what I do is what now? I'll subtract a to the nth power minus what now? Minus n. Right? Let me give you an example of this. If I have 7 raised to the power of 5 divided by 7 raised to the power of 3. This becomes what? 7 to the fifth power minus what? 3. So give me what? 7 to the second power. That's what the law is saying. You have the same base and then they have what now? They're dividing. Two values dividing each other. Subtract their power. Now let me try and make an example of it in the other way like I did earlier on. Very quickly. We had 7 raised to the power of 2, remember that? Or 7 to the second power. So if I'm going to go by this, I have 7 to the fifth power divided by 7 to the third power. This can be written as 7 to the 5th power divided by 7 to the 3rd power. And what is 7 to the 5th power? 7 times 7 times 7 times 7 times 7 all over 7 times 7 times 7. So now we what now? We strike out. This 7, 1 here will cancel this 7. This 7 here will cancel this 7. This 7 here will cancel this 7. So what I have left is just what now? 7 times what? Times 7. Because everything there is gone. So I end up getting what? I end up getting this to be equal to 7 raised to the power of what? Of 2. Like we had earlier on. I'm sure you get that. You can take your time. One of the things that will help you while you are practicing or whatever you're doing is to do it over and over again. This is the second law, proven. Let's hurry to the third law. Okay. Second law. Yep, let's put it there. Now let's go to the third law. For the third law, I have what? A to the a raised to the power of 0 is going to be equal to what now? 1. Anything to the power of 0 is equal to what? To 1. How do I prove this? I have to do the second law backwards. Let's say, for example, I have a raised to the power of, let me do it backward like I said. I have a raised to the power of 5 divided by a raised to the power of 5. Anything divided by itself is equal to what? It's equal to 1. So if I have anything divided by itself, a raised to the power of 5 divided by a raised to the power of 5, it's what now? It cancels out. So they give me what? 1. So like I said, I want to prove it in a reverse manner. So this will be equal to what? A to the power of 5 minus what? 5 from the second law. When we are dividing, we subtract what? The powers. So I end up getting what? A raised to the power of 0. So simply, a raised to the power of 0, anything raised to the power of 0 is any power at all divided by what now? By itself. So if I want to run it backward, I can say that a raised to the power of 0 is the same thing as a raised to the power of m divided by a raised to the power of m. Because a raised to the power of m divided by a raised to the power of m. Okay, I'm running too fast. Let me get backward a little bit. I can say m minus what now? Minus n. Anything minus m is 0. So m minus n is 0. Then I can go a step further. Going backward, a raised to the power of m divided by what? A raised to the power of n. Because we know that what? This can come back this way. And maths, like if you can get the answer from the word now, from the question can also give you what now? The answer. But I'm sure you get the gist. Anything raised to the power of 0 is that thing, is something, a power divided by what now? The same power. So that will give you what now? 0. Anytime you have anything to the power of 0, it gives you what? It gives you 1. So let's go to the next. Let me take this out. Alright. Now the third. Let's go to the fourth. For the fourth, I have a raised to the power of negative n. Anytime you have a negative power, you just simply reciprocate. Let me try and emphasize something before we go further. I have said to you guys before that anytime you have a number that doesn't have a denominator, the denominator is what? Is 1. So if I have 7, and 7 doesn't have a denominator, it's the same thing as what? 7 over what? Over 1. If I have 20 without a denominator, it's 20 over what? Over 1. If I have 15, it doesn't have a denominator, it's 15 over what? Over 1. If I have x, it doesn't have a denominator, it's x over 1. So anything, any number that doesn't have, any value that doesn't have a denominator, the denominator is what now? Is 1. Alright, so let's sort that out quickly. Let's get back to business. I know I'm running very fast, you have to forgive me. Alright, so this is what I'm having here. This will give me 1 over a raised to the power what? Of n. Well, how do I get this? How do I prove this? Right? I can say that a raised to the power of negative n is the same thing as what? A raised to the power of 0 minus what? Minus n. 0 minus n is still negative n. 0 minus n will still give you what now? Negative n. So following that law that I just showed you now, the second law, this can be equal to what? To this. Right? Because this, when you have the same base dividing, you can what now? Subtract what? The powers. So from here I can have that what? This is a raised to the power of 0 divided by a raised to the power of n. And we already have proven that what? Anything raised to the power of 0 is what? Is 1. So I have 1 over a raised to the power of n. Alright? So this law is true. But now let me show you variants of the law. Variants of this particular law. So that when you're solving questions, you will not have troubles with it. This law is also called the reciprocal law, right? For indices. So if I have something like a over b raised to the power of what? Negative n. In order for me to take away the negative sign, I just what? Reciprocate. This is the same thing as what? As b over a, and then the sign changes. Even if it is positive and you want to change to negative, you reciprocate. As long as you reciprocate, the sign of the power must what? Must change. So if I have something like 14 over 12, okay, let's say 14 over 17, raised to the power of what now? Minus 2. This is going to be the same as what? As 17 over what? 14, and the negative sign goes away, and I have to do what now? Second power. Just make note of that. This is the fourth law. The law of what now? Reciprocal. Right? The reciprocal law for what? For indices. Then for the fifth law states that if I have, okay, I didn't write that. This was a raised to the power of negative n to give me what now? 1 over a raised to the power of n. So let me push it that way quickly. Okay. Make it smaller. For the fifth law, help me, please help me. If I have a to the what? There's a power inside the parenthesis or inside the bracket and a power outside the bracket or outside the parenthesis. I'm going to have what now? The power inside the parenthesis multiplying the power outside the parenthesis to give me what? A raised to the power of mn. Alright? Because n times n is same as what now? Mn. Understand for algebra? If I have what now? AB is same as what? A times what? Times b. Alright? That's just a reminder. So let's go further. Let me try and prove this quickly. If I have something like a to the second power and then third power outside, what does this mean? A to the second power means that I have a times a. Raise the power of 3. And what is this? So I'll end up getting what? A times a times a. So at the end of the day, I have what now? A times a1, a times. That's what a to this. That's like 3 times. We have this times what now? Times that. Is that okay? So I end up getting what? 1, 2, 3, 4, 5, 6, 8. So the a raised to the power of what? 6. So instead of going through all this stress, Ali, stop that. Instead of going through all this stress, I'll have to just multiply straight to give me a 2 times what? 3. So give me a raised to the power of what? Of 6. Is that easy? So if I have a power inside and I have a power outside, I just multiply them out and I'll get what I'm looking for. I'm sure you get the explanation. I told you I'm running as fast as time can contain, but if I'm too fast, you can replay and then you watch again, alright? So that you will understand it better. This is the fifth law. Let me go to the what? To the sixth law. The sixth law is fractional indices. I have a and then the power is what? I say fraction. A raised to the power of 1 over what? Over n. In this case, I'll have what? This. When I have the power, I don't want to prove this because I don't want to waste your time. Alright? This one, it's not like the proof is possible, but I don't want to waste time. If I have the fifth law, the seventh law is a combination of the fifth and the sixth law. Okay, before I go to explaining while I'm solving the questions, I'll give you an example to prove this law. Right? So this is the sixth law. Then the seventh law is a combination of the fifth and what now? And the sixth law. So I have something like a raised to the power of m over what? Over n. Take note. For fractional indices, your numerator forms the power, your denominator forms the root. So if I have fractional indices, definitely I'll end up getting what now? Root. Right? This is even as a to the nth power like I had here. Then in this case now I have a to the nth power. Sorry, to the nth root and the what now? The nth power. So the numerator forms the power, the denominator forms what now? The root. And like I said, before I go to solving questions, I will explain them. So let's run backward a little bit. This is what? This is law 6. And this is law what now? Law 7. What did you just do? Okay. And this is law what now? Law 7, right? So let's just do a recap very quickly. The first law is this. The second law is this. The third law is this. The fourth law is this. The fifth law is this. The sixth law is this. And then what now? The seventh law. Remember I told you the seventh law is a combination of what? Of the fifth and what now? And the sixth. Is that okay? Thank you very much.